Got another video here on Algebra Essentials. This one deals with rational exponents. 7 problems. Just to remind you some of the formulas. If a is a real number and n is greater than or equal to 2 is an integer, then a to the 1 over n can be expressed as a radical. That would be the nth root of a, provided that the nth root of a exists. If the index is even, 2, 4, 6, and so on, then a has to be positive. If the index is odd, a cube root or a fifth root or whatever, then it can be any real number, negative, positive, 0. Also, if you have a to the m over n power, you can write it a couple of ways. The nth root of, in the radicand, a to the m, or it can be written as nth root of a, all in parentheses, taken to the m power, where m and n are integers containing no common factor. So you want these in lowest terms, the m over n. So you always want to reduce that if you can. So again, these are the problems. You can pause the video wherever you want to see if you can work these out. So let's look at the first one. We have a to the 2/3 power. So we can do this a couple of ways. I can write this as the cube root, based on the formulas we saw, the cube root of 8, and then the n, this is 2, that could come here squared. Then you'd have 8 squared. So the better option is to put the exponent outside this way. So you can put it inside, you can put it outside. But this way you have the cube root of 8 is 2, and then you take that to the second power, that's 4. So the answer is 4. Now you can also set it up this way using the properties of exponents. You can say, well, 8 is taken to the 2/3 power. I can write 8 as 2 to the 3rd. And then the exponent outside there still stays 2/3. And then a power to a power, you multiply the exponent. So 2/3 times 3, the 3's cancel out. I get 2 squared. And I get 4. So the answer is still 4. Now for the next one, we have 4 to the 3/3 power. I could do the same thing on this one. I can either say the square root of 4. I'm sorry, the square root of 4 is 2. And 2 to the 3rd is 8. That's what we did. Okay, I'll go ahead and write it out. So it's the square root of 4. I can put the power here, or I can put it outside. It's easier to take the square root first and then take the power. Let's deal with smaller numbers. The square root of 4 is 2, and then you take that to the 3rd power. 2 to the 3rd is 8. Now if I don't want to use the radical formula, then I would just say, well, 4 is the same thing as 2 squared, and then put that in parentheses and leave the 3/2 outside. So I just rewrote 4 as 2 squared, and then 2 squared to the 3/2 power, multiply the exponents, power to a power, 2's cancel out, and I get 2 to the 3rd, which still gives me 8. Okay, go to the third one here, negative 27 to the 1/3 power. Now this one again, I could use powers, but I'll just write that as the cube root of negative 27. Negative 3 to the 3rd is negative 27. So not much to do here. That's negative 3. Okay, the next one. Again, 16 to the 3/4 power. Again, you can just do it in your head if you want. The 4th root of 16 is 2, right? Because 2 to the 4th is 16. And then you cube that, you get 8. Or you can write it this way and say, okay, 4th root of 16. And that's taken to the 3rd power. See, I could put the exponent inside and say 16 to the 3rd, but see, that gives you a larger number, harder to work. So it's easier if you take the root first and then the power. 4th root of 16 is 2. And then you take that to the 3rd power. 3 factors of 2 is 8. And again, I can set it up this way without using the radicals. I could just say 16 is 2 to the 4th. And that's taken to the 3/4 power. Power to a power, multiply exponents, so these cancel out. I get 2 to the 3rd, still get 8. Now keep in mind that when you're working with rational exponents, the rules are still going to be the same. If you have, say, x to the 1/2 times x to the 1/3. The roots are still the same. Multiplying powers the same base, you add the exponents. If you're dividing powers the same base, you subtract the exponents. Power to a power, you multiply. So here we're just going to add the 1/2 and the 1/3. Got to find a common denominator, which is 6. So multiply this by 3 on the numerator and denominator, so it's going to be 3 over 6. Over here, multiply by 2 to make this a 6, and the numerator by 2, it'll be 2 over 6. So bring down the base, add the exponents, we get x to the 5 over 6. So those rules that I covered in other videos, still the same for rational exponents. This cancels. Now here I have 9 to the negative 3/2 power. Well, again, one formula that we need to know here. We can actually prove this, derive it, but if you have a base taken to a negative power, in this case negative n, that would be the same thing as 1 over a to the n. And of course the restriction is that a cannot be 0 because you cannot divide by 0. So for this one here then, I would just say, okay, it's a negative, so let's just, this tells me you have a negative power. To make it positive, bring it to the denominator. So all I do is bring this down to the denominator, and the exponent becomes a positive 3/2. And then the rule now is still the same as what I did. So it's 9 to the 3/2 power. So what can I do? I can cube the 9 and then take the square root, or I can take the square root and then cube it, just like the other ones. So in this case, this would be 1 over square root of 9 is 3, and then 3 squared is 27. Now for this one, we have 9 over 8. So this one is going to be exponents positive. This would be the same thing as the square root of 9 over 8. Again, I could cube this whole thing, but it's easier if I work with that first. So let's look at this then. Let's look at the part inside the parentheses. Yeah, the square root of 9 over 8 would be the same thing as the square root of 9 over the square root of 8. And 9 is a perfect square. The square root of 9 is 3. And 8 is not a perfect square, but it has a square factor that we can bring out. 4 times 2. So the square root of 4 is 2. And then the 2 stays under the radical, so we get this. Okay, so then we come over here, and then replace this by 3 over 2 times the square root of 2, and then we're cubing that. So let's rationalize this here first. Multiplying by the square root of 2 here, this would give me 3, and then square root of 2 on top here, then the square root of 2 in the bottom gives me the square root of 4, which is 2, and then 2 times 4. This will be 4 actually. Multiplying by the square root of 2 on top, I get the square root of 2, and then square root of 2 times the square root of 2. The square root of 4 is 2, and then times 2 is 4, and then this is cubed. And this is going to equal to 3 to the 3rd power, that's 27. And then the square root of 2 cubed is the same thing as the square root of 8. 3 factors of radical 2 would be the square root of 8. But again, the square root of 8 can be written as 4 times 2, or 8 can be written as 4 times 2. So square root of 4 is 2. That comes outside. And I'm left with the square root of 2 there. And then in the bottom I'll have 4 cubed, that's 64. So the 2 divides into 64. So final answer then for this one will be 27. Then this 2 we divide into the 64. 32 times, so this will be 32. I got the square root of 2. That's your answer for that one. Okay, let's do this. And then for the last one, we have 8 over 27 to the negative 2/3 power. Yeah. You play around with the formula for a negative exponent. If you have a over b to the negative n power, then this is the same thing as 1 over a over b to the n power. So here this would just be a to the n and then b to the n. A to the n, b to the n, and then you multiply the numerator and denominator by the reciprocal of that, and this would give me b to the n over a to the n. But I can rewrite that using the properties of exponents. Instead of b to the n over a to the n, I can write that as b over a to the n power. So what I'm trying to tell you here is anytime you have a fraction taken to a negative power, just take the reciprocal of that. This will be 27 over 8, and change the sign of the exponent opposite what it is. So in this case it will be 2/3. And then it works just like the first couple that we did or so. You have a cube root and a square. So we can either square it and then take the cube root, or take the cube root and then square it. Well, I choose to take the cube root first. The cube root of 27 is 3. The cube root of 8 is 2. Then we square it. 3 squared. Again, when you're taking a fraction to a power, you should take the numerator and the denominator of that power. So 3 squared is 9. 2 squared is 4. So the answer to this one is 9 over 4. We'll have some more on hyperbolas a little bit later on, some other videos. And I'll be having some more of these algebra essentials, different topics, kind of like a review of algebra stuff that you should be able to do, hopefully. So when you get into high school or college algebra in college and so forth, stuff you should know, just a review. Thanks for watching, and we'll see you next time.